Today we're going to talk about polynomial long division. And before we start talking about the polynomial long division, we need to refresh our memory on how to divide numbers. It's not that you have to know how to divide these numbers. It's that you have to know the process. Because the process isn't going to change when we apply it to polynomials. And what we do, this is 951 divided by 7, is we're going to set up our box. 951 divided by 7. Once we have it set up, we ask ourselves, how many times does 7 go into 9? Well, 7 goes into 9 one time. And then we take 1 times 7, which is 7. Do you remember what we do now? We subtract it. We're going to subtract that 7. And 9 minus 7 is 2. And then we're going to bring down the 5. And we go through that process again. How many times does 7 go into 25? Well, 7 goes into 25 3 times. 3 times 7 is 21. And again, we subtract. 25 minus 21 is 4. And we need to bring down the 1. And we ask ourselves the same kind of question. How many times does 7 go into 41? Well, it goes in there 5 times. And 5 times 7 is 35. And yet again, we subtract. 41 minus 35 is 6, which is our remainder on this problem. So off to the side, the question says, is 7 a factor of 951? Well, no. And the reason that it's not a factor is because there is a remainder. So a couple things to know. The 7 is called a divisor. The 951 is called a dividend. And the answer to a division problem is called a quotient. I'm not super picky about the vocabulary, but at least we should recognize those terms. And I should also recognize that what I think you should know and what you do know are two separate things. But when we factor a polynomial, what we're trying to do is we're trying to find something that goes into the polynomial. So we're looking for a factor of the polynomial that gives a quotient. So the quotient, the answer to the division problem, is going to be another factor. And then we may have a remainder, which sometimes we abbreviate as R. And what happens with the division is that sometimes it can help us factor. If we're really struggling with factoring, we can try to divide and come up with our other factor. But as we get ready to approach our long polynomial division, there is one thing. Our format needs to be correct. And it is that our polynomials need to be in standard form. That means that the highest exponent goes first and the next highest exponent and so forth. So this means that both polynomials have to be in descending order to actually divide. Now, whether you're watching the video or whether you're in the classroom right now, the thing about the long polynomial division is it might not be something that you immediately understand. It probably needs a couple of examples before you understand. So as we take a look at our first one, use the polynomial long division. Divide 4x squared plus 23x minus 16 by x plus 5. And we want to identify the quotient, again, which is the answer to the division problem, and the remainder. So off to the left of the screen, we've got our steps. And the first step says divide 4x squared by x. And that's where this is coming from. The 4x squared is underneath the division bar, and then the x is outside the division bar. So we'll start there. 4x squared divided by x. If we write this out longhand, and some of you need to do that and some of you don't, this is 4xx divided by x. X squared is x times x. The only reason that I would do that is so that I recognize that one of the x's cancels out, and what's left is going to go up here as part of the quotient. We're left with a 4x. Next step says multiply 4x by the entire value, by the entire divisor, the x plus 5. So it's going to be 4x times x is 4x squared, and 4x times 5 is 20x. It was positive 4x times positive 5, which gives us a positive 20x. And our next step says subtract to get 3x. Well, instead of subtract, what I frequently say is change both signs. So we're going to change a sign here. We're going to change a sign there. And now we can actually do the subtraction. 4x squared minus 4x squared cancels out. 23x plus a negative 20x is 3x. There's where we subtract to get 3x. And then we need to bring down the negative 16, or the minus 16. We're going to repeat the process now. What we're trying to do is we're always trying to get rid of the highest degree term. In this case, now it's 3x. So we're going to take 3x divided by x, and where the x is coming from is here. That x right there that I just highlighted. We're dividing by that. Luckily on this one we don't have to write anything out longhand because 3x divided by x is simply 3. And that's what's going to go up here on top of our division bar. We're going to take those values and we're going to multiply. 3 times x is 3x. 3 times 5 is 15, and it's positive 3 times positive 5. Change both signs. And when we do, 3x minus 3x cancels out. Negative 16 plus negative 15 is negative 31. Will negative 31, or can we take negative 31 and divide it by x? No. So our next question here, we're done with the math part of this. The next question is, what is the quotient? Well, the quotient is the 4x plus 3. And the negative 31 is the remainder. When we look at this problem a little bit more closely, down here at the bottom, it says the factor theorem, the expression x minus a, is a factor of the polynomial if and only if the value a is a 0 of the function. So example, if x plus 2 is a factor, then what happens is we would take the x plus 2 and we'd set it equal to 0, get x equals -2. So that's where it says, then you should be able to plug in -2 back in for this x at x cubed, and 3 times -2 squared minus 4 times -2 plus 12. And when we calculate that on our calculator, we should get 0. So if we look at our problem that we just did with the long division, in the above example, x plus 5, so there's our divisor, x plus 5, well, it does not divide the polynomial 4x squared plus 23x minus 16. But what we can say is that x plus 5 is not a factor, and the value of -5, which by the way comes from x plus 5 equals 0 and subtract 5 from both sides, so we get x equals -5. That's where it came from, is not a root. Because the other thing that we could do is we could take that -5 and we could put it back into this function here. We could say 4 times -5 squared plus 23 times -5 minus 16. And we would not get 0 for our answer, which means that it's not a factor. But as we flip our paper over, really what we want to focus on today is how do we do long division? And now that you've seen one, hopefully this one will make a little bit more sense. But what we're going to do is we're going to take this x cubed, because we're dividing, x cubed plus 2x squared minus 5x plus 12. We're going to take that value, x cubed, and we're going to divide it by x. And once again, where that x is coming from is here. It's that value right there that I just highlighted. Well, if you're not familiar with your exponent rules, x cubed is x times x times x divided by x. And one of those x's cancels out. And we end up with x squared. That's what's left. We canceled out one, so we've got this, still those two. And once we determine what goes up top, we're going to take x squared times x, and we get x cubed. X squared times 4 is 4x squared. They were both positive. Positive x squared times positive 4. And then we're going to change both signs. Change here, change here. And when we change, x cubed minus x cubed cancels out. 2x squared plus -4x squared is -2x squared. 2 minus 4, if you have to type that in your calculator. Then bring down the next term. In this case, it's going to be minus 5x. We're going to do that again. So let's take our -2x squared. And we're going to divide by our highlighted x again. And what that means for us when we do the division, if we need to write it out longhand, is it's -2 times x divided by x. And when we write it out longhand, it shows up pretty well that the x's cancel out here. And what's going to go up there on top of our division bar is going to be the minus 2x. We need to be careful with our signs. But it's -2x times x is -2x squared. -2x times positive 4 is -8x. Change both signs. That's the subtraction process. And when we change both signs, negative 2x squared plus 2x squared cancels out. Negative 5x plus 8x gives us 3x. And then we need to bring down the next term, which is our plus 12. We want to get rid of the highest degree term. And now what it is it's 3x. It's going to be 3x divided by x, that value in yellow. 3x divided by x, the x's cancel out. It's positive 3x divided by positive x, which is going to give us positive 3. And it's 3 times x is 3x. 3 times 4 is 12. Change both signs. Change both sides. And what we see when we finish here is that 3x minus 3x cancels out. 12 plus a negative 12 cancels out. So in other words, what happened on this problem is that there is no remainder. So now that we've divided, we can go back and answer this question. Is the divisor, which by the way is x plus 4, is the divisor a factor? Yes. Last one. 4x to the fourth minus 5x squared plus 2x plus 4 divided by 2x minus 1. We need to watch out because we're missing a cubed term. We still need to answer that same kind of question. Is the divisor, which in this case is the 2x minus 1, is that a factor? And we'll know when we actually do the division. But we do need to be careful because we need to leave at least a space for the cube term. We need to have a spot for every degree. So it's going to be 4x to the fourth. I personally like to write plus 0x cubed, just as a place marker. Then we have minus 5x squared plus 2x plus 4. Descending order, like I said, standard form. We're going to divide by 2x minus 1. And we're going through this process here where we have to get rid of the highest degree term. We're going to be using this 2x here, is what we're going to be using to help us divide. So in this first part, we're going to start with 4x to the fourth divided by 2x. The first thing I'm going to do is circle 4 divided by 2. 4 divided by 2 is 2. And then we've got x to the fourth divided by x. So 1, 2, 3, 4 divided by x. And our x's cancel out. So we've got 2x, x, which is 2x cubed. First value of our quotient. We're going to take that value and we're going to multiply it. 2x cubed times 2x is 4x to the fourth. 2x cubed times negative 1 is negative 2x cubed. Change both signs. And when we do, the 4x to the fourth, one's positive, one's negative, cancels out. We have 0x cubed plus 2x cubed, which is 2x cubed. We're going to bring down the next value, minus 5x squared. We're going to repeat the process. Two x cubed divided by 2x. We could start with the numbers here, and 2 divided by 2 is 1. So what we really need to worry about is the x cubed, which is x and x and x, x times x times x, divided by x. But what happens is that x cancels out, and we're left with xx, which can also be written as x squared. I'm going to use that value. X squared times 2x is 2x cubed. X squared times negative 1 is negative 1x squared. Change those signs. And when we do, the 2x cubes cancel out, and we've got negative 5x squared plus 1x squared, which is negative 4x squared. Negative 5 plus 1. We need to bring down the next value, which in this case is plus 2x. And we're going to go through the same process again. Negative 4x squared divided by our highlighted value there of 2x. Starting with the numbers here, negative 4 divided by 2 is negative 2. And then we have x, and x. And one of those x's cancels out. So what's going to be part of our quotient is going to be the minus 2x or negative 2x, depending on how you look at it. Minus 2x. And we're going to take that value. Negative 2x times 2x is negative 4x squared. Negative 2x times negative 1 is positive 2x. Change those signs. And as always, negative 4x squared plus 4x squared, it cancels out. 2x plus a negative 2x also cancels out. If you have to, you can write a 0 down. But as we look back at the problem, we still have to deal with the fact that we still have a plus 4 up here. But can we divide 4 by 2x? We can't. So this 4 down here is going to be our remainder. If you saw the directions on the last problem, it says write the remainder in fraction form. So what happens is that 4 is a positive. So we're going to put plus because it's positive. And then it's going to be 4 divided by 2x minus 1.